Hello friends, I'm Jagdish Park Associate. Today's topic is strength of materials. So in strength of materials, I'll be deriving axial deformation formulae from the chapter simple stresses and strains. Okay, so before going to this video, please press the subscribe button of our channel, the Mechanical Engineers team, and also click the bell icon so that you will get the notifications for new videos. So let's begin. Now I will give the definition of axial deformation. When a component is subjected to axial loading, the length of the component will be increased or decreased. So this kind of change in length due to axial loading is known as axial deformation. Now I will give the definition of axial loading. If a load is applied on the axis of the structure or component, then such kind of loading is called axial load. The axial load may be tensile or compressive. If a tensile load is applied on the axis of the structure or component, then such kind of loading is called axial tensile load. If a compressive load is applied on the axis of the structure or component, then such kind of loading is called axial compressive load. Okay. Now I will give an example for axial deformation. The best example for axial deformation is spring. Take a spring of length 10 cm. Now hold the spring on both the end. Now try to pull the spring on both sides with equal force. After pulling, if the length of the spring is changed to 12 cm, then the axial deformation value will be 2 cm. To be more precise, the length of the spring on the right end is increased by 1 cm and the length of the spring on the left end is increased by 1 cm. So therefore, the total axial deformation value is 2 cm. Suppose if you compress the same spring by applying equal force, after compression, if the length of the spring is changed to 7 cm, then the axial deformation value will be 3 cm. Which means the right end of the spring is decreased by 1.5 cm and the left end of the spring is decreased by a length of 1.5 cm. Therefore, the total deformation value is 3 cm. To be precise, the axial compressive deformation value is 3 cm. Now we will get into the derivation. For finding the formula of axial deformation, we will use uniform circular rod. First of all, what do you mean by uniform circular rod? The shape of the rod will be circular and the area of the rod will be uniform throughout the length. So such kind of rod is known as uniform circular rod. Now we will apply tensile load on both the ends of the circular rod and also on the axis of the circular rod. Due to this application of tensile load, the circular rod will undergo increase in length or change in length on both the ends. So this change in length or increase in length is known as axial deformation. Now I will list out the terms which will be used in this derivation. First, the length of the circular rod is L. Second, the diameter of the circular rod is D. Third, the area of the circular rod is A. Fourth, the axial tensile load applied on the circular rod on both ends is P. Fifth, the Young's modulus of the circular rod is E. Sixth, the change in length or increase in length on both the ends of the circular rod is taken as dl. So these are the terms which will be used in this derivation. Okay. First we will find the formula of area of the circular rod, which is taken as A. So the formula for area of the circular rod is pi by 4 into diameter of the circular rod whole square. So here diameter of the circular rod is D. Therefore, A is equal to pi by 4 into D square. So the area of the circular rod is pi by 4 into D square. Next we will find the formula of tensile stress of this circular rod, which is taken as sigma. First of all, why we have to find the formula of tensile stress of the circular rod? Why? Because the circular rod is subjected to tensile load on both the ends, due to which the tensile stresses will be automatically developed inside the circular rod. So for finding the value of tensile stress, we have to find the formula of tensile stress of the circular rod. Okay. So generally, the basic formula for stress is force by area. So here tensile stresses are developed. Therefore, the formula for tensile stress will be tensile force divided by area of circular rod. So the tensile force here is P and the area of circular rod is pi by 4 into d square. So the next step will be sigma is equal to P whole divided by pi by 4 into d square. Now I am going to apply algebraic rule on this tensile stress formula. And the algebraic rule is A whole divided by B by C is A into C divided by B. Okay. So in this tensile stress formula, I will take P as A, pi d square as B and 4 as C. So according to algebraic rule, I can rewrite this tensile stress formula as sigma is equal to P into 4 divided by pi d square. Right? So here P into 4 is 4P. So the next step will be sigma is equal to 4P divided by pi d square. Which means the tensile stress formula of this circular rod is 4P divided by pi d square. Next we will find the strain formula of the circular rod, which is taken as epsilon. First of all, why we have to find the strain formula? Why? Because the circular rod is subjected to axial load on both the ends, due to which the strain will be automatically induced. Due to this strain, the circular rod will undergo change in length. Okay, so that's why we have to find the formula of strain, and the basic formula for strain is change in length divided by original length. So here change in length is dl and original length is l. So the formula will be epsilon is equal to dl by l, which means the strain formula of this circular rod is dl by l. Next we will derive the axial deformation formula, which is taken as dl. For deriving the formula, we will use Young's modulus formula. So from Hooke's law, the Young's modulus formula is stress by strain. So according to this circular rod, the Young's modulus formula will be tensile stress divided by strain. We know the tensile stress formula, which is 4P divided by pi d square, and strain formula, which is dl by l. So substitute both the formulas in this Young's modulus formula. So we get E is equal to 4P divided by pi d square whole divided by dl by l. Now I am going to apply algebraic rule on this Young's modulus formula, and the rule is A by B whole divided by C by D is A into D divided by P into C. So in this Young's modulus formula, I will take 4P as A, pi d square as B, dl as C and L as D. So according to this algebraic rule, we can rewrite this Young's modulus formula as E is equal to 4P into L divided by pi d square into dl. Right? So here 4P into L is 4PL, and bring this dl to the LHS and E to the RHS. We get dl is equal to 4PL by pi d square E, which means the axial deformation of this circular rod is 4PL divided by pi d square E. Okay, so friends, this brings an end to the explanation part of this video. I hope you all would have understood. If any doubts are there, please do comment in comment box, and remember to like, share and comment on our videos. Thank you friends.